Hello and welcome back. For this video, we'll be covering Module 6, Lesson 1, Part B, solving one-step inequalities. You'll notice that the goals here are the same. The exceptions are going to be that instead of adding and subtracting, we're going to use multiply and divide. We have a couple of properties we've got to make sure we understand. If we multiply or divide each side of an inequality by a positive number, and that's important that it's positive, then the inequality remains true. However, if you multiply or divide by an inequality by a negative number, make sure it's a negative, then the inequality must change direction to remain true. That's an important rule that a lot of people seem to overlook, and that's mostly the difference between inequalities and equations. So if we look at our multiplication property of equality, we have a true statement right here, 5 is greater than 2. Then we multiply by a positive 4 on both sides. We'll end up with 20 greater than 8, which is a true statement still. Even if we made them negative numbers, so negative 5 and negative 2, what we're multiplying on both sides is still a positive 4, so I'll end up with a negative 20 less than a negative 8, which is still true. However, if I multiply by a negative number on both sides, the fact that these two numbers were negative to begin with don't matter. It's the negative that I'm actually multiplying on both sides with. I end up with 20 is less than 8, which we can clearly see is false. So in order to fix that, we're just going to flip the sign around, and now it's true. The same thing is true with division property of equality. So I've got 10 is greater than 4. If I were to divide both sides by 2, I'll end up with 5 is greater than 2, which is still a true statement. Or if I start with negative numbers, negative 10 is less than negative 4, and that's a true statement. But when I divide by a positive 2 on both sides, I still end up with negative 5 is less than negative 2, and that is still a true statement. However, if I go and divide by a negative on both sides, the fact, again, that these were both negative to begin with doesn't matter, but I'm dividing by the negative on both sides. I'll end up with 5 is less than 2, which we know is false. So in order to fix that, we have to flip the sign around, and now it becomes true. All right, so our first example here, we want to solve and graph. So the first thing we're going to do is get rid of the negative 2/5. So we're going to multiply both sides by negative 5/2. And when we multiply this left-hand side by negative 5/2, this becomes a positive 1 times x, which is x. And because I multiply by negative here and a negative here, this inequality must do an about face like that. And I'll end up with negative 55 over 2. Actually, it's exactly equal to negative 27.5. So when I go to write this as a solution set, I'll say all x's such that x is greater than or equal to negative 55 halves. And on the number line, I'm going to have negative 27 here and then negative 28 here, which means negative 27.5, which is what I'm really looking for, would be right here in the middle. So I'm going to go ahead and put a solid dot there because I have an equal to over here on my number line, or my inequality. And I'm looking for values of x that are bigger, so my arrow will be to the right. For my next example, actually we've got an error here. This is supposed to be a 4. That's supposed to be a 4, so change that to a 4. And then to solve for x, we're going to divide by 20 on both sides. And because I'm dividing by a positive, my inequality does not change. But I can reduce the 4 over 20, which we'll call 1/5. So the solution set would be all x's such that x is less than or equal to 1/5. All right, so I've got a 0 here. This will be a 1. And 1/5 is a small decimal, much closer to 0, so I'm going to put my dot right about here. That's approximately 1/5. Now remember, I'm doing x's that are less than 1/5, so that'd be an arrow to the left. Okay, for this check problem, we want to select the solution set. Now, a little test-taking strategy here, especially when we have multiple choice. When we see that this coefficient here is negative, when I have to get rid of that negative, we know that this sign right here is going to change this direction. So what I'm really looking for is an x is less than. If you look at choice A, it's got x is greater than, so that can't work. And if I look at choice C, it's got x is greater than, so I know that can't work. Now I got to look at my answer choices here and here to decide which one is which. I don't actually have to divide this out because if you look at the right-hand side, you'll see it's a negative, and I have a negative over here, and a negative divided by negative should be a positive, so I know the answer's got to be positive, so it's got to be choice B. Okay, for our next example, we want to write and solve an inequality from a word problem. Alyssa has read 1/4 of a novel of, this word right here, of, is an important one, of a novel. If she has read at least 112 pages, how many pages are there in the novel? So the question is, how many pages are in the novel? So I'm going to let a variable p equal number of pages in novel. So of means time. So 1/4 of a novel, meaning the pages in a novel. So I have 1/4 of p. And then I have this 112 is on the other side. Now, how do I write my inequality? Because it says at least. That means the 112 is the smaller of the two. So my inequality must face away from the 112. But also because at least means it could equal 112. So I got to put an equal sign here. In order to solve this, I'm just going to multiply both sides by 4, which is the reciprocal of 1/4. This will give us a 1. 1 times p is p. P is greater than or equal to, and then 112 times 4 is 448 pages. So the book has at least 448 pages in it. For our last example here, we're going to write and solve another inequality. Let's just say an inequality. For every hour X that Ava's electric car charges, she can drive the car 7.5 miles. So X is hours. Ava needs to drive at least 60 miles tomorrow. So write an inequality for this situation in terms of X hours. So after 1 hour, she gets 7.5. After 2 hours, she gets 15. So it looks like the pattern there is to take 7.5 times it by X hours. And then she needs to drive at least 60 hours. So I'm going to leave a space and put 60. And at least 60 means 60 is the smaller of the two. So I must make this face away from 60 because it's got to open towards the bigger value. And at least means equal to. So there's my inequality. All I got to do to solve it is divide both sides by 7.5. So I'll do this out to the side. So 7.5x over 7.5 is greater than or equal to 60 over 7.5. And that will leave me with x being greater than or equal to 8. Now remember, x is in hours, so that would be 8 hours. So she's got to charge it at least 8 hours so that she can drive the 60-mile minimum that she's going to be doing the next day.